Hi everyone, so in this video I'm going to explore two options for the NV200 range extender project. The first option is to use a pre-made inverter generator, as you can see here. So the way they work is it's basically a Honda GX200 engine, a copy of one anyway, which has just got a big generator bolted onto it. So the stator on that generator would most likely need rewound because it's also got a 12 volt winding inside it as well usually. Every inverter generator I've taken apart has had the high voltage three phase winding as well as an extra 12 volt winding just sort of stuck in there. So that would need to come out in order to maximize my power output. Drawback with this design is really that it's only going to give me about 3.5 kilowatts. It states here that the rated output is 3.1 to 4 kilowatts with a peak of 3.5, but I reckon I could get probably 3.5 kilowatts continuous, as we're not converting to AC anymore. It's just the three phase out of the generator going straight to DC and then charging the vehicle rather than getting converted to single phase AC again. So I'm confident I should get a fair amount of power out of that. And I just need to develop a high voltage VESC based inverter board for this, which should be much less complex than the other solution which I'm going to show you. It'd be reasonably easily done. I just put sufficient insulation around hall sensors. I could put hall sensors in this so it can start the engine a bit more smoothly, and also well insulated temperature sensors for the windings so that the VESC would just throttle back if the thing was getting too hot. The VESC would be controlling the throttle, as well as how much load is getting put on the generator unit in there. So obviously the exhaust would be routed out the van somehow, and that's something that I'm capable of doing. The next option is bolting the Kia Niro HSG onto a larger sized Honda GX engine, probably something in the region of 14 horsepower. So the Kia Niro HSG is just like it's about the same size as a normal car alternator, but it's much more powerful. This can output 8 kilowatts either as a motor or generator, so it's very compact and powerful. It's also water cooled, which adds a bit of complexity, but that 8 kilowatts would be really nice. The thing is though, how am I going to mount an A-section belt pulley onto that? Most pulleys that you get for these small industrial engines are like A-section belt pulleys, taper lock bushes, things like that. I don't think there's anything on the market where you can just put you could get a serpentine car alternator belt pulley which then has just a 22mm keyed shaft hole in it. I don't think such a thing exists. It would have to be custom machined, custom made. It would be very expensive. Or we somehow get the A section on there, but I'm not even sure that's possible because it's not really a sort of standard size shaft that's on there. I think most of the A section pulleys are made for like induction motors and small engines. They're not really, I don't think they're made normally for alternators, apart from the alternators that come with that pulley already on them. That's probably going to be the main sticking point for going down this route. That would then be connected to the BMW i3 range extender inverter, and I've made a drop-in board for that, which is almost done, but sadly this project would have to be stalled because I need to get this done by the camp trip, so this would maybe get stalled if I go down the cheap inverter generator route. So this board would go in the BMW i3 range extender inverter, but the issue with it is it's going to be quite an expensive board to make. That's if we cannot get the resolver drivers working with VESC. The AD2S1210, which comes with the original BMW i3 inverter, the intention was to remove that and solder it on there, saving £20, but the VESC does not currently support that driver. It supports the AD2S1205, which costs £20, and you could just use it straight out the box pretty much, along with the rather expensive resolver excitation amplifier. Those are about £5, so that adds considerably to the cost as well. But this would be a good option because it's already controlling a very well designed power stage. But it's obviously, we've got the complexity then of water cooling. For the air-cooled inverter generator, probably what I would do is I would just have one of those sort of, those spinning vents that you normally see that are like on the back of, I don't know, police vans where they have the dogs, etc. I might just put one of those on top of the van, or maybe just some sort of air scoop that faces just backwards and has a powerful fan just blowing the air out, just so that the back of the van doesn't get too warm. And that's something that would need to be sorted out, just so there's proper ventilation. Ideally, there would be negative pressure in the back of the van when this thing's running, so that just in case there's a tiniest little leak from the exhaust, there's no chance of that going where it's not supposed to. And I'd obviously have like a carbon monoxide detector just in the front with me, just in case like the worst was to happen, even though it's like super unlikely if you know how to secure an exhaust to an engine properly, because engines are used in quite a lot of situations. They're used inside buildings for generators quite a lot, with the exhaust running outside. So if it's done right, it's not a problem. But yeah, those are our two options. The only thing to do now before I choose one of them is to do a feasibility study. I've got a big pure sine inverter which I'm going to tap into the DC, route that through a very large current limiting resistor in the form of a convection heater, and then connect that into the high voltage battery on the NV200 and see if the car flags up any problems with 2000 watts being dumped into the battery while it's just switched on and sitting idle. I'm not sure if it would work or not. I think it would, because people normally, when they make range extender packs for the NV200, they just put the extra pack in parallel with the existing one, and there may be situations where power would flow from that pack into the existing pack, and I don't think it causes problems, but I'm going to do a test on that, and that's for the next video. So sadly I've got nothing for you at the moment, but once my little ramps arrive, I'll be able to get the van up and then have a look at what the connections are like.